Welcome back. In this part, we're going to take a look at the control registers. Okay, so the 32-bit instruction pointer register and the 32-bit flags register combined are considered as the control registers. Okay, so many instructions involve comparisons and mathematical calculations and change the status of the flags, and some other conditional instructions test the value of these status flags to take the control flow to other location. Okay, so let us take a look at the common flag bits. Okay, so the common flag bits we have, the first one is called the OF. Okay, OF, or called the overflow flag. Okay, so we have the next one, which is called the DF, which is the direct flag, and the IF is the interrupt flag, and TF, not TP, TF is called the trap flag. We have this one is called the sign flag, F sign flag, and we have ZF is called the zero flag, and we have the AF called the auxiliary carry flag. Okay, and even the PF is called the parity flag. Okay, and lastly the CF is called the carry flag. Okay, so the OF, this one indicates the overflow of the higher order bit, okay, which is the leftmost bit of the data after a assigned arithmetic operation. Okay, so we have the direct flag. This direct flag, this one determines a left or right direction for moving or comparing string data. Okay, so when the DF value is 0, the string operation takes left to right direction, and when the value is set to 1, the string operation takes right to left direction. Okay, so the IF, which is called the interrupt flag, this one determines whether the external interrupts like the keyboard entry and many others are to be ignored or processed. Okay, and it disables the external interrupt when the value is set to 0, and enables interrupts when it is set to 1. Okay, so we have the TF. Okay, we have the TF flag, which is called the TF, the trap flag, and this one allows setting the operations of the processor in single step mode. Okay, so the debugger program we used sets the trap flag. Okay, so we could step through the execution. Okay, one instruction at a time. Okay, so we use that one. Later, and yeah, like that, and previously. Okay, so we have the signed, we have the sign flag. Okay, the sign flag, and this one shows the sign of the result of an arithmetic operation. Okay, and this flag is set according to the sign of a data item following the arithmetic operation. Okay, so the sign is indicated by the higher order of the leftmost bit. Okay, and a positive result clears the value of SF to 0, and negative result sets it to a 1. Okay, so let us take a look at the 0 flag, which is ZF. Okay, so this one indicates the result of an arithmetic or comparison operation. Okay, so a non-zero result clears the 0 flag. Okay, and sets it to be 0, and a 0 result sets it to 1. Okay, so let us take a look at the AF, okay, which is called the auxiliary carry flag. Okay, and this one contains the carry from bit 3 to bit 4 following an arithmetic operation. Okay, and this one is used for specialized arithmetic. Okay, so the AF is set when a 1 byte arithmetic operation causes a carry from bit 3 into bit 4. Okay, so we have another one, which is called the parity flag. Okay, and this one indicates the total number of 1 bits in the result obtained from an arithmetic operation. Okay, and an even number of 1 bits clears the parity flag to 0, and an odd number of 1 bits sets the parity flag to 1. Okay, so we have another one, which is called the CF. Okay, the CF, they are known as the carry flag. Okay, and this one contains the carry of 0 or 1 from a higher order bit, which is the leftmost, okay, after an arithmetic operation. Okay, and it also stores the contents of the last bit of a shift or rotate operation. Okay, so let us take a look at this table here. We have a table right here. Let me show it to you. We have a table there. So here, as you can see, in the first row, we have the flag. Then in the second row, we have bit number. Okay. So O represents the overflow flag, and D represents the direction flag, and the I represents the IF flag, and T represents the trap flag, and S represents the sign flag, and the Z represents the zero flag, and A represents the auxiliary carry flag, and this one P represents the parity flag, and lastly C represents the carry flag. Okay, so in the next part we shall take a look at other registers like the segment register. Okay.